The procedure for finding the inflection points of a function f. Step 1. Compute f double prime and determine all points in the domain where f double prime equals 0, where f double prime does not exist. That's what we do when we go to find max mins. We do the same thing with second derivative, but it's going to give us a different set of information. For each number found in step 1, determine the sign of f double prime to the left and the right. So we pull a test point, check it out. If f double prime is positive, concave up. F double prime is negative, concave down. F double prime is 0, potential inflection point. Doesn't mean it is 1, but it is a potential inflection point. I never use the second derivative test, by the way. I get the information I need from, actually, just from the first derivative. Second derivative test. Suppose f double prime exists on an open interval containing c, and f prime of c equals 0. So the first derivative is 0. If the second derivative is positive, then we have a minimum. If the second derivative is positive, it is concave up. And concave up means min. If the second derivative is negative, that means concave down. And concave down means max. Now, I can do that from the first derivative, right? Increasing followed by decreasing is a maximum. I don't need to use a second derivative to tell me it's going to be a maximum. I just look at my little number line, and that number line tells me whether it is or not. Now, it's a nice cross-check, so here we go. We're going to be doing this on your worksheet today. From a graph. In exercises 1 through 4, determine where the second derivative of the function is positive and where it is negative. Now, second derivative, positive, concave up. Second derivative, negative, concave down. So, down, up, down, up. So where the break points are there. Now that's where these are inflection points. Inflection, inflection, inflection. That's where concavity changes from concave down to concave up. So I just use my pencil, right? Down and then changes to up. Down, then changes to up. So concave down from minus infinity to negative 4, then goes up from negative 4 to negative 2, then goes down again from negative 2 to 1, and then goes up again from 1 to infinity. And where you have the change in concavity are inflection points. If I were to look at this thing on a number line, there's an inflection point, so that's a critical number. There's an inflection point, so that's a critical number. There's an inflection point, so there's a critical number. Concave up, concave down, concave up, concave down. That's what we'll see on our number line. Down, up, down, up. Where the second derivative is positive, we have up. Where the second derivative is negative, we have down. Just like you do with the first derivative, only the only difference is that you're getting a different piece of information. And of course then, if they didn't ask us this, inflection points, x equal -4, x equal -2, x equal 1. It's got 3 inflection points. With a max at 0 and a min at 2. They didn't ask us that either.